Hi guys, welcome back to my channel, and today I'm going to be making a video of the editorial, the first problem in the DP contest on AtCoder. I would suggest that all of you try this out if you're trying to learn DP. It ranges from like super fundamental problems like this one to very hard problems at the end, and I'll be making editorials for all of them. And I would suggest that you guys would try them out, and if you have any issues with them, then look at the editorials just to learn DP well. It's a great resource. So, in the first problem, you have n stones with a different height, and your goal is to reach the nth stone with the least possible cost. So, from stone I, you can either jump to stone I plus 1 or stone I plus 2. And the cost is just the difference of the height of the stone you were at originally and the height of the stone you reached after that jump. And you just want to find out how to get to the last stone with the minimum possible cost. So let's look at this first example here. We have 4 stones with a height 10, 30, 40, and 20. So what we know is from each stone I, we can either go to I plus 1 or I plus 2. And the cost is just the difference between those heights. So the first one, you're at that stone at the beginning, so you start with a cost of 0. Now, from 10 to 30, the cost is 20 for that jump because 30 minus 10 is 20. And so the minimum cost to get to 30 is 20 because there's only one option. Now for 40, it's a little bit different because there are two options here. You can either get to 40 from 30 or from 10. So how do we determine which one is best? Well, all we need to do is we take the cost that it takes to get to 10 and 20, and to those we add the cost of the jump. So for 10, the jump from 10 to 40 would be 30, and for 30, the cost from 30 to 40 would be 10. So in this case, if you sum those up, they actually have the same cost. So the minimum cost to get from the beginning to 40 is 30. So now for the final one. For 20, you can either get there from 30 or from 40. And since we know the minimum cost to get to 30 and the minimum cost to get to 40, we can calculate this very simply. The cost to go from 40 to 20 is 20, and the cost for the jump from 30 to 20 is 10. So if we add these up, the cost to get the minimum cost to get to 20, assuming we're at 30 right before, is 30. And if we're coming from 40, it's 50. So that makes our final answer here 30. And that is the answer, as you can see here. So by storing the minimum cost like this, the answer for each stone I, the minimum cost to get there, is only dependent on the previous two the previous two stones. And since we store the minimum cost of those already, we don't have that operation is extremely fast. So this is a textbook DP. DP of I, which in this cost is the minimum cost to get there from stone 0, is equal to the minimum of DP of I minus 1 plus the cost of that jump from I minus 1 to I, and the DP of I minus 2 plus that cost. So now let's look at the code. It's very simple. So first we read in the input, which is just n, the number of stones, and a of n will store all the individual stones. And initially, we'll keep all of the DP values as int max because right now they don't have a min cost because we haven't been able to finish the DP yet. So it just makes it convenient to calculate this minimum. And DP of stone 0 is already 0 because that's where you start out. So from each stone, you simply do this DP transition, but it's in reverse. You can also implement it this way, but in this case, we're implementing it where from I, you can either go to I plus 1 or I plus 2. So you simply do the minimum of whatever the DP is currently, and the jump considering if you come from the ith stone, which is the DP value here plus the cost of the jump. Okay, I hope you guys gained some insight by solving this problem, and I hope you liked this video. If you liked it enough, please like and subscribe, and stay tuned for the rest of the editorials. See you next time.